chaotic. Unfortunately, I do not have those on the recording, but we just installed Pygame on everyone's virtual machine. So what I need you guys to do, because we did create a separate folder where we create this virtual environment and where we're going to be where we installed Pygame. Let's go ahead, open up the curriculum, and I'll show you what it should look like. Let me share my screen. Right, so you should have your regular lesson. I don't believe I formatted them, so the last lesson. Oh no, do I not have it in here? Now it should all be in here. No, is it not updated? Oh no, I knew something was off. Okay, um, because you guys don't have the updated repo, I'm going to go ahead and drop some stuff on the FOP Slack channel. Okay, what I'm going to drop off in there is going to be this. Stand by. I thought I had it. I apologize. Where is it? New lessons. Give me a big eyes. I'm trying to get this working. Okay. Where the heck is it? Uh, oh, I don't know what's going on with the repository. It should have had it. Unfortunately, it does not. Uh-oh. All right, I'm gonna drop for you guys two important folders. It's going to be an assets folder and a sound folder, right? These are going to be the assets that we're going to be using for the program. We don't have to go out there and look for any kind of images or sounds. I will have this for you. This is where I build the curriculum. I'll be dropping this file in there too. And dropping it all within the FOP Slack channel. So stand by. What you guys are gonna do is you're gonna download the computer, and we're gonna use I'm gonna need you guys to move the assets and the sounds to the directory that you guys created uh in your virtual environment. Okay. And
So, quick question, Roger. Like I downloaded, well, not downloaded. I did everything on that Pi game, and the
okay,
game worked, but I didn't create no folder, no virtual environment folder.
that's fine. Are you Ubuntu or Homebrew?
Ubuntu. I mean, I'm on a Windows using WSL using
You're
Ubuntu.
good. It seems to be a homebrew issue. I don't know why. It's very nitpicky. So we had to create the virtual environment for them. So you're perfectly fine. Don't stress.
Okay. All right.
Uh, why can't I copy this? Anyone else have any questions while I get this working? All right. Okay, here we go. You should be seeing it in the FOP Slack channel. Attach recent file, upload from computer. Sorry, it's giving me issues with uploading the files. Okay, it's loading up. So I need you guys to download these, right? And then put them all within uh somewhere in your um on your desktop, all right, and ensure it's within the folder for Pygame. All right, I'll give you guys 2 or 3 minutes to do that. Give me a thumbs up on the chat, not a reaction, when everyone is ready to go, or it's downloaded at least.
You said this is supposed to be in the FOP channel on Slack.
Correct.
Okay. I don't know if this is the same for anybody else, but I don't see it yet.
I see it. It's up.
For the rest of you guys, once you guys have it downloaded, right? What you should have, once you guys get it, it should look something like this. I need you guys to um put it in a Pygame folder, right? I want you to create an assets folder. This assets folder, I want you to put the images that were given to you guys, right? It should be a spaceship as well as 3 different aliens and outer space, right? The next things that you guys will have will be sounds folder. I need you to create that folder in there, add your retro background music and your shoot one in there, and then you should have a README, right? That README is going to be what we're going to use as a code along. It's not a perfect README. I did this over a weekend, so do not hit me. But it should be enough to get us going and have something documented. Owen, do you have it?
I'm starting to download them all. We need to download
Okay.
all of these.
Yes, mate.
Okay.
Okay. Why is it not here? I'm so bummed out. I apologize. It should have been on your repository, but I'll probably give you guys an outdated one. And that's on me. Very unprofessional on my part. It won't happen again, I promise.
Shit happens, brother. You ain't perfect, man.
Thank you. Appreciate it.
Okay, now and you said we need to make 2 directories, right?
Yeah, so within your plugin folder, make a assets folder and a sounds folder. right? If I'm still sharing, your folder should look like this, guys, right? A blank directory with three things: an assets folder that stores all your images, a sounds folder that should have both of your MP3s, which is the background music, and the shooting sound. Right. Go ahead. Make sure you guys are giving me those thumbs up on the chat once everyone's done. I see Daryl, I see Danielle. Who else is ready to go? Nobody? You guys are still downloading and making these directors? While you guys are doing this, this is just for the recording itself, for anyone that's going to view this later on. So the first part of today involve installing Pygame onto our virtual machines. For some reason, we had some issues with Homebrew. The way that we went around it was creating a virtual environment. So we essentially had to open up our console, and then we had to run. Well, first and foremost, we had to ensure pip was installed, right? So we just went ahead. We upgraded pip as well because sometimes they can get outdated. So we did Python -m pip install -- upgrade pip. That upgraded our pip if it needed to be upgraded. And then we wanted to create our virtual environment. So we created a directory where we're going to host our Pygame folder. So call it Pygame folder, went into the directory, so we CD'd into it, and then we created a virtual environment, right? That way we can install Pygame without affecting anything else that we've installed onto our computer. So what we did was we created that virtual environment by using the command. Let me see. I forgot what it was. It was Python -m space VENV for virtual environment space, and then whatever you want to call your virtual environment. Right after you run that command, it should create the virtual environment for you. And then to activate the virtual environment, we had to use source space, and then we gave you the path of where our virtual environment was called. So that path started with whatever you call your virtual environment. Let's say it was XYZ, so it would be XYZ /bin, with a B as in Bravo, /activate. That activated our virtual environments to allow us to install Pygame. Afterwards, we went through the process of installing Pygame by using the Python -m pip install Pygame, right? So pip install Pygame, and then we ran the pygame.examples.aliens command that was given to us throughout the documentation, and that installed Pygame for us. For anyone that's in Ubuntu, you should be able to run the commands that are within the Python documentation for the Ubuntu section. It's straightforward. We didn't have much issues there. Following that, we went ahead and we downloaded the assets that were added onto the FOP Slack channel into our Pygame directory that we had created, and that's where we are at now. So is everyone good to go, guys?
I believe so. I
Okay.
might not have everything though. So I just need a working directory, a sounds directory, and all of the pictures and the README and all of that. Other than that, I don't need anything else.
Nothing else. We should be good to go. Pygame's installed. We have the asset that we need for the class. I'm gonna start the next 2 minutes, and then if you guys ready to go, then you're ready to go.
Okay.
We've already spent an hour on this. I want to make sure that we actually get to some class. I do apologize for the fact that it took us an hour to do this. I would just hate for someone to not be able to get the actual lesson if they're allocating this time to me. We'll get a glass of water for this last minute. Be back. All right, I am still a little sick, so I do apologize if you guys can't understand me. If I do mispronounce something or you don't understand something I say, do stop me and I'll uh repeat myself. All right, guys, time is 6:30. So we're gonna go ahead and start. We're gonna go into our README and kind of look through it and what it's asking for us. Now, to make this a little bit more readable, on the top right, you should find where it says Open Preview to the side, and it has a magnifying glass. If you click that, it'll give you a representation of what that README should look like whenever it's on GitHub. So it makes it a little bit more readable. It adds some formatting to it, um, which is nice, right? So it's not just raw text, right? So this is an extra class that I developed. This is the third time I run this class. The first time that I ran it, we didn't have these issues. We were able to get it up and running within like 10 minutes. Unfortunately, Pygame, like every other framework out there or library or module, constantly gets updates, and sometimes these updates don't match the state of where our computer is at, right? So we had to adapt to that. So this is an extra class for object-oriented programming. Now, I have to say that, right? Because there is a misconception that, oh, why are we learning Pygame when it's not part of the curriculum? The reason why we are using Pygame is because we are utilizing it as a tool to facilitate our learning and understanding of object-oriented programming and their principles, right? Pygame itself is not an actual framework. It's nothing big. It's just a small library that Python has. Doesn't normally just come with Python. We have to install it just like we saw here. And it comes with its own methods and functions, just like everything else that we've used, whether it's math.random, whether it's statistics, right? Everything we've imported, it had like its own built-in methods. Pygame has the exact same thing. Once again, I need to state, this is not a lesson on Pygame. This is a lesson on object-oriented programming. We are just using Pygame as a tool to get a better understanding of how objects work, right? And being able to visualize these objects whenever we instantiate them, right? So you know what's actually happening, right? Because we hear these words like, instantiating an object, or, the class is a blueprint for the object. What does that actually look like? For some of us who are visual learners, it can be a little difficult to try to wrap our head around what that looks like when it's just raw text. And I built this lesson to help you guys who are more visual learners try to understand these concepts, especially after this last Lemonade Standout Pie. I feel like a lot of us struggled there. I received mainly 90% positive reviews on this assignment. The 10% were people that just were stubborn, like, I didn't want to learn Pygame, but they don't understand the main reason for it, okay? So I provided for you guys the entirety of the assignment is in this README. If you look at this README, look how long this is. This will take you from start to finish, step by step, on completing the entirety of the program. You are essentially not really having to learn Pygame because I did it for you. It's just coding along and then using classes and objects to see how that ties in to other programs and for us to visualize what our objects are doing, right? So there shouldn't have to be any headaches, right? You don't have to memorize any of these commands or methods. As we code along, I'm coding with you guys. You guys are coding on your screen. You guys are asking questions as we do this. What is this? What is that? Why is it doing this? Yada yada, and just having fun with it, right? learning while coding is the main goal here, right? Um, so I did all the hard work for you, no actual needing to bust your head into your monitor, just soak in the information and just enjoy the process and seeing how your objects come to life. Okay. So at the very start of this README, we have the installation process. As you might already know, it's a little outdated. All right. Obviously, if you would have gone through the README, it wouldn't have worked. We had to go around it because things change. Right. Uh, Here we have the Pygame method cheat sheet. All right. So unfortunately, this isn't a Pygame lesson. It is an object-oriented programming in classes lecture. So we won't dwell too much on Pygame libraries or methods. All the legwork has been done for you, and all you need to do is use the boilerplates provided for you. A small description has been added to familiarize you with the module we will be using. Pygame will simply be a tool for us to better visualize classes and objects. And here is your Pygame cheat sheet. All right. Right off the bat, we have our boilerplate, right? And I'll talk about this in a minute. Below the boilerplate, we have the basic commands that go into Pygame that we will be utilizing. So if at any point you forget how to use a command, you kind of come up here and see where the commands are at. But let's actually get this bad boy onto our screen. So on your file, I want you to create, I'm sorry, on your folder, I want you to create a new file, right? And this file is going to be called Pygame. No, not Pygame. It's going to be called main.py, right? This is going to be the main loop of our program. So it's going to be main.py, right? So main.py. Now, our main.py is where we're going to hold the main actual concept of our game, the game loop. For those of you who are not familiar how games run, imagine it as a big while loop, right? When you run the game, it's just running through these commands over and over and over again, like 1,000 times per second. That might not be exactly accurate, but just know that this program will run multiple times, and every time it runs, it's checking the state of your program, right? When we talk about state, we're talking about like where your images are at. Has anything moved? Have we updated the positions? Have we added a new image? Have we declared any new variables? It's running multiple times per second. All right. So we have to create what we call our game loop. Now, we're going to go ahead and initialize Pygame. Pygame is essentially a big object, right? And to initialize Pygame, we will use the command pygame dot init, right? Notice the init, right? That's very familiar. We have an import issue here. Why is that? Well, because I didn't import Pygame. Right. So we're going to have to import Pygame. So we have access to Pygame's methods and functions, which one of the functions that comes with it is its initialize function. Right. Up to this point, you guys are already familiar with our class and objects. We have to use the init method to initialize our objects. And Pygame is no different. It has its own method to kind of boot it up, just like your computer has a power button, or your car has the ignition switch. Pygame has its init method to start up, right? So we import our Pygame library and we use the init method to initialize the Pygame module in our code. Now, once we initialize Pygame, we now have access to its methods. So we are going to create a small window, which will be our sandbox, right? It's going to be our canvas where we're going to create our objects and bring them to life. To create a window, Pygame has a method called pygame.display, and then it uses a method called .setMode, right? And what the set mode does, it takes in arguments that give your window dimensions, right? Whether it's going to be 800 by 800, 1,000 by 8,000, or 400 by 800, right? We're essentially going to give it our dimensions, how big we want our display to be. Notice that all these commands I'm using are straight from the README. We're taking it step by step from the top. It's just the next one within our cheat sheet. All right, we are creating the boilerplate for our main game. Right. So this creates the window and it sets its size, right? So within set mode, we're gonna open up another pair of parentheses. Notice that when I hover over the set mode function, it takes different parameters. The first one it takes is coordinate, right? We have other stuff here, flag, def, display, vsync. We don't need all that right now. The only thing we need is the first argument, which is going to be the coordinate. So we're going to open and close parentheses within these parentheses for the first argument. We see here, once again, size. And we're going to set this to 800 by 800. Right? All right. Now, next, this is cool and all. We have our screen. Next is adding a clock to our Pygame. So, recall the conversation we had about game loops. Well, for those of you guys who play video games on your own, you guys probably heard the term frames per second, right? FPS, frames per second, right? When your frames drop or they increase, is how many frames your computer can track at a moment. And we need to track the frames of our game. And to track that, we have to create a timer, right? So to create a timer, we're gonna do pygame dot clock, as I was not pygame dot clock. We just have to do clock is equal to pygame dot time dot clock. Right, this will create a clock for us so we can track the frames and everything that's happening within our game. Right. All right. Give me a second. Where is it at? All right. Stand by. I'm trying to find something for you guys. All right. So we assigned our clock. One thing we're gonna want to do is our display. We're going to assign it to a variable as well, right? This variable is going to be called screen, right? So our screen, we assigned it our display. We created our clock and assigned it to the variable called clock, right? And next we're gonna have to do what else? Okay, maybe I'm getting ahead of myself. Okay. Sorry, I haven't touched this in a while. All right. So these two methods right here create our screen and our clock, right? But because this is an object class, what I'm going to do is I'm going to add these bad boys to a class, right? This class is going to be called game. And then I'm going to add these into our init method. So just like we're able to create something like this individually, we're able to do this within classes, right? Why manually code it every single time we want to do something when we can create class and then create the object itself. So we're going to add these two methods to a game class. And within this game class, we're going to do define underscore init and self, right? And it's going to be something very simple. The only thing we're going to do here is move these within our init method, right? As well as the pygame.init. right? So I want you guys to move your pygame.init within here. It's going to initialize the pygame module within this class. So whenever we create the game object and we run it, it will automatically have pygame initialized within it, right? And then the screen and the clock, the only difference that we have to change here, because it is a class, how do we assign data members to classes in it? Is by using the self method, right? Self dot underscore screen is equal to the dimensions that we just declared. Cool. And same thing for the clock. Self dot underscore clock is equal to pygame dot time dot clock. Okay. So we could have done it without the class in objects, but we're gonna go ahead and do it in our class to understand how we can do this within an object, right? And just like we set these variables, we can do that by setting them into data members. So whenever we instantiate our game object, it'll automatically populate these data members to what a screen should be and what the clock should have, right? Now, next, we're going to go ahead and create a method for this game. And this method is going to be called run, right? Whenever we create our object game, it should have an ability to actually run our game. And this is where the actual functionality is going to be added in, right? So by doing game.run, it should start our game process, right? So within here, if you guys recall, I said it was essentially just a big loop, right? Our program or game loop should be just a constant loop that just runs over and over again until we decide to stop. Just like you decide when to turn off your computer, just like you decide when to exit out of game because you played too much, or you're done driving, you go ahead and turn off the ignition, you turn off your computer, it should have a condition, right? And the easiest way to do this is by using a while loop, right? While I'm running, I should have it true. When I'm not running, it should be false. So we'll add the functionality within our while loop, which is going to be while true. So while this is true, I want to check some conditions. I want to check for events. So when you guys open up your browser and you click a button, what does that do on your browser, right? Let's think back to our JavaScript, right? What does a button have to have for it to actually work? What methods did we use for that?
An event listener.
An event listener, right? We added an event listener for a button. And everything that we did, whether it's a button, a drop down, whether we clicked on an input tag, whether we hover over a button, that itself is an event, right? And games work very similar. They have events, whether you press a button to attack an enemy, whether you press the X button on the very top of your window to close down the game, all those deals are events, right? And Pygame tracks events, right? These events are stored within a dictionary, and this dictionary can be accessed by using pygame.event.get. Right, this returns a dictionary of all the possible events within Pygame. And the reason we do this is that we want to see when an event is happening, right? When did we click anything? Did we exit out of our game? And if you guys remember, I said that our game loop runs at like 1,000 times per second. So every second that passes, this while loop runs and checks what has happened, right, throughout that second. So every time that second passes by, this runs 1,000 times to see what the heck is happening. So to check what's happening, we're going to use a for loop. So for events in pygame.event.get. All right, so we do a for loop. So while we run this while loop, it's checking all the events that are happening within our game. Right? It's looping through this dictionary of events, and then we want to check if one of these events is whether we quit the game or not. And this is going to allow us to close out of our game window. So if event.type is equal to pygame.quit, right? The event that we're looking for is the quit event. You guys don't have to memorize this, just knowing that Pygame has an event called quit. So if one of the events that's happening is that we want to quit the game, then we need to tell Pygame to quit, like to actually close out the window. So to do that, we have to do two things. We have to run the command pygame.quit, open and close parentheses. And then for redundancy, what we also do is we manipulate our system to actually manually quit the window, right? So Pygame might not be running, but sometimes you might get some weird functionality where even though the program's not running, the window might stay open. So we have to access our system and directly close that window down. So to access our system, we have to import a method called sys, right? This will manipulate certain things like your actual applications on your desktop. And we can do, within this for loop, we'll do sys.exit. And you'll see how this works right now in a bit when we actually visually see it. Okay. All right. Now, outside of this for loop, right? After we've checked for this, outside this for loop, I want you guys to come back to the indentation where your for starts, right? Still within the while loop, but outside of the for loop. We're going to run a command called pygame.display.update, right? And why do we run this command? Well, let's say hypothetically we have an image on our screen, and then we make that image move by updating its X and Y axis. Well, the position of that image has moved, but the display hasn't tracked that change yet, right? So Pygame has a method called update that'll go through everything that is within its file. It will check if the current status or location of those files are still where they should be at, or if they still hold these same values. If they don't, then we will update them, right? So pygame.display.update will allow us to do that, right? And then we also are going to set our clock to tick, to actually work. So we've created the clock, but we haven't set the clock to do something. Self._clock, right? So we're gonna call the clock data member, and we're gonna set the timer to 60 frames. Right? Now, this should be everything that we need. Now we could move forward, I believe. Okay, now that we've created our basic game class, outside of our class, we're going to create a game object, or yeah, a game object. So we'll call this my game is equal to game. Notice that we didn't add any arguments within the game class, so it should just be something as simple as open and close parentheses. Now we want it to run, so we're going to call the run method. So my game dot run. Now, if we did this right, we should be able to run it. But notice we got an error, right? We saw the window popped up, but it closed. That means there's something wrong with our code. Let's look at this. It says pygame.time has no attribute clock. Did you mean clock? I might have misspelled this. Might have to take a lower uppercase C. So let's change that. Run it again, and we get this. A basic window. Now, let's go ahead and take a step back, because everything that we probably covered was probably a lot for us to understand. What did we just do? Well, we had to create an object. Notice that when we define this object, this is the blueprint for it. This is all this code from line 4 to line 20 was able to create this simple black window for us. Let's look at the code again. Where did this code come from? We initialized pygame.init that allowed us to use the pygame methods within our class, right? After that, we created a screen variable, right? And this variable is holding our screen. We set the screen to 800 by 800 using the display.setMode method. We then created a timer. You can't visually see the timer, just know that in the background, this timer is keeping track of any changes in our window. Then we created a method called run that starts a while loop, right? Why is this window still up constantly? Well, because this while loop is constantly stays true, right? This is a never ending loop right now that is constantly just running this window and keeping it open. While this variable, this Boolean is true, we are checking for events. It's checking if we have pressed the X button. Where is it checking that, right? Right here on pygame.quit. Have we exited the game? If we did, then we should close out this window. That's what lines 16 and 17 are doing. One stopping pygame, and the second one is closing the window. Right? And then every time it's checking whether we quit or not, at the very end of it, it's going to update any changes that were made to the window. And we're once again just setting the clock to 60 frames. Very simple. Does anyone have any questions so far? These are all built-in methods that come with Pygame. All we did was use the methods and assign them to variables, right? And then we ran them by using the while true method. That's all we did. All right,
What was the purpose of the program? What was the purpose of lines 19 and 20 again?
19 to 20. So this updates our screen. So right now there's nothing here, right? But imagine there was an object here that was a spaceship, right? This spaceship is set at the X coordinate 400 and Y coordinate 400. Therefore, it's probably dead center in our screen. Well, let's say we move that spaceship up 10 10 spaces on our X coordinate, right? And it shifts in our screen. Well, we might have shifted the position of the image, but our window is still tracking its original position, right? Where X is 400 and Y is 400. But we just changed the X to 410, right? So that means it should move. Well, our window needs to track that it's now no longer in the same spot. So line pygame, I'm sorry, or you're asking about this, right? The display, the update. Yeah, so it updates the screen. So it goes back, it checks all the data members. Hey, are these all still the same? Has anything moved? Has our background moved? Has any of the images moved? If anything on our display has moved, then I need to update my screen so I can now display this. Right? And then line 20, it caps your frames at 60 frames per second. So what are frames per second? So every time this run, this isn't just a perfect seamlessly stream of images. These are frames. Think of them as snapshots, right? Snapshot. Every time you take a picture, it's like when you guys use your iPhone and you take that like 10 pictures at a time. I don't know if you guys know what feature I'm talking about. There's one where you can do like a timer and it'll take like 10 different pictures in the split of a second. And then you can go back and you thought you took one picture, but you took like 10. So that's kind of what it is, right? It's multiple frames and it runs them fast to make it look like one single image, right? So the clock is tracking how many frames are being ran per second, right? So this is just like an imagery thing, a display thing. That's what line 20 is doing. This is not an object-oriented programming thing. This is just a gaming thing. So no reason to get too hemmed up on that. Okay. So we got our screen. Now let's add some background to our screen, right? we're gonna add some background within our game data. Remember, let's go ahead and close this out. We can press X and it should close out for us. Why? Because we added that functionality here on line 16 and 17 where we quit, right? So it's able to quit for us. What happens if I don't add this? Notice, I'm gonna run this and I go press X and nothing is happening, right? You have to manually code everything that you want your screen to do because we didn't add some functionality to check when we're quitting. It does not let me close this window up. So if to close it, I'm gonna have to stop the program directly on my console. Notice that the window is no longer here. Let's go ahead and undo this. Now, once again, we're checking what events are happening. One of the events was that we wanted to quit. So therefore we stopped Pygame and we closed out the window. That's what line 14 to 17 are doing. Does that make sense now of why we need that? Good. So
Yes.
we have the basic foundation of our window, but this is too plain. This isn't sexy, right? It's not sexy at all. Also notice,
Black?
what was that?
You don't like black?
Ain't nothing wrong with black, but we want to add some color into this bad boy, right? Make it a little bit more diverse, right? So we want to add some imagery to this. But notice also at the very top, we have something pretty bland too. Pygame window. That's pretty freaking lame. Let's change that. Well, how do we change that? We have a method that comes with Pygame. This method is called pygame.display.set_caption. Right. This method allows us to change the text of our window. And I want you guys to add here a string and call this bad boy Space Invaders. Right. Run it again. Notice that the text at the very top is now changed thanks to the method that came with Pygame. So we were able to change our game object. Notice this window is an object, guys. Right off the bat, you already visually seeing a representation of an actual object, right? We created the class here, guys, right? And then we instantiate the object and then we run it. We are visually seeing the representation of an object right now, right? Objects are things, right? You can make them whatever you want, right? Now,
So so if this was in another file, we could make many different games just by passing in a string if we wanted to set the window display, right?
say that again. I don't think I understand the question you're asking.
Okay, so this is a class object, right? So if if we were making different games, right? And what we could do is just pass in a string to the set caption, and that would give us back different objects of those games, right?
You can do, let's see if this works. I should be able to do my game 2 is equal to game,
Uh,
right? And then let's run both of these. My game 2 dot run. I got one over here. It's not letting me run a second game.
okay.
But I could make a different type of game in a different file. So yeah, it looks like this is strictly for one game right now. Maybe
Okay.
it's a Pygame thing that only lets me open up one window.
Okay.
But yet you could make some other game in a different file and then open that one up. So you can create multiple ones of these, but you're going to run one at a time, it looks like.
Okay. Thank you.
No problem. All right, guys. So now that we have a window open, we can begin working. All right, first thing we'll do is create a surface that we can work on, right? Think of it as your desktop, right? What we just created essentially was our desktop, right? but whenever you guys open up a browser, it opens up a window on your desktop, right? So we have our overall big scale concept of what a window is, but to actually do stuff, we open up windows and applications to do things in those windows, correct? Think of it like that. We need somewhere we can draw on to add stuff to it, right? So we're gonna create what we call a surface, right? Keep in mind that this display screen is not the same thing as our working surface, right? Think of it as the display as your table, right? But you don't draw on the table. What do you draw? You draw on a piece of paper, right? On a different surface. You don't just draw directly on the table, which in this analogy, it's our display. We need something that we can draw on. So we're going to create a surface. And once again, like in our analogy, that is a piece of paper that we can actually draw on and add some images on, right? To create a surface, you require the pygame.surface command. We will begin by declaring a data member, which will hold and initiate our surface, and we will give it the outer space.png file. So we see here, right? We have to declare our surface within our init method. So at the very bottom of our screen, clock, and display, let's go ahead and add some space into it. I'll add some comments here. Creates the main window. And then down here, let's call this creates a surface. All right. So we know where the main functionality is at, but now we need to actually start adding some stuff to our nice little game that we are creating. So to create a surface, we're going to declare another data member. It's going to be self._space surface, right? And then to create a surface, we use the pygame.surface command. So pygame.s for surface, or capital surface. And then just like display, it takes in different arguments. The first one being the coordinate, and that's the one that we care for right now. So we're gonna go ahead, open and close parentheses, and we'll say 800 by 800. We want the surface to take the entirety of our window, right? We already set the display to be 800 by 800. Now let's also set our surface to be the max width and height that we already have. All right. So in our analogy that we used earlier, where we had our desk and our piece of paper, what we've done so far in this analogy is we pulled out the piece of paper, right? And we are setting it on our table, right? But we haven't set it on our table yet. We have confirmed it is the same height and width as our table, but it's not placed on the table yet. We need to place it on that table, which in this situation, it's our window, right? So to place it, we're gonna go within our run method, and we actually have to manually place it onto our window. And to do that, we're gonna do it between the for loop and the display.update. So this is, we'll add some comments here, checks for events. Down here, we're gonna add another comment where it says updates window. And then here between both of these is where we're gonna actually add the surface, right? So we're gonna do self dot screen blit is the command, right? And what screen blit does, it allows us to add stuff to the surface. And I'm having an issue here. It's giving me, oh, I see what the issue is. I'm using private data members, my bad. So we're grabbing the screen that we declared earlier, right? Notice it's up here. This is the display. We can actually change this. We'll call this display so we don't get confused. So screen._display. We'll come down here, update as well. We're going to grab our display, which is in our analogy, our table, and we're going to blit our surface onto it. In other words, we're going to place our piece of paper on our table, right? Blit, it allows us to place our surface down. Now, that blit method takes two arguments. It takes the surface you want to add onto it, and it takes where you want the surface to be, right? So what surface do we want to add? We want to add our space surface. So let's go ahead, add self._space surface. Now, where do we want this surface to be? Well, when we add images into our display, uh, where is it placing it at, right? If you just give it a random coordinate, how is it placing it? Is it placing it dead center, right? Is the coordinates dead center of the image? Or is it taking it by a corner? Well, I'll show you guys how that works. In the meantime, the position we're gonna add is gonna be open and close parentheses, 0, 0. And I'll show you guys how that works in a bit. Visually, I'll show you, right? So we've placed it on our surface. If we run this, we don't see anything yet. Our surface is black, just like our display, right? You don't see it yet, but just know there's a surface on here. Now we can actually draw on our piece of paper, right? Our piece of paper is now on our desk, aka our display, right? It's covering the entire of our table, our display. But now we can actually draw on that surface. So to draw on it, we want to call that surface up. So we'll say self dot underscore space surface. And then we're going to draw on that surface. So notice initially we drew on the display. What did we draw on it? We put our surface on it, our piece of paper. Now that the piece of paper is on it, we can draw on the piece of paper on line 27. So the same way that we placed our piece of paper on our table, just like we did here on line 26, where we put our surface on the display. Now the display is no longer needed. We can just draw on the surface itself. So we're gonna blit on that one. What are we gonna blit? We are going to blit our image that we have already within our assets, right? I already got that for you guys. It is the outer space.png. To add an image in Pygame, you have to use pygame.image.load, open and close parentheses. Within these open and close parentheses, you're going to add the location of your image file, right? So I'm going to do open and close apostrophes or quotation marks. And then I'm going to add the file that I want, which is gonna, as we see here within our asset, it's called outer space.png. So type in the name of your file. And I want you to give it a location, right? Because it takes two data members, the image you want to load onto it and also the location. So add 0, 0 for now. And let's see what that does for us. Okay, it's giving me an issue. Why do you think it's giving me an issue? Who can guess this one?
It's not in the same directory.
It's not in the same directory, right? It's within the assets folder. So we actually have to give it a file path. I'm not gonna lie to you guys, I'm not really good at this one. So let's kind of experiment a little bit. I want to say to go into a directory, we have to go into assets / outer space. And if we run it, we see that it loads our image, right? Because it wasn't the same directory, we had to tell it where to go. We want to go inside of assets. And then after you go inside of assets, get the outer space.png. And then it recognizes the location of our image and it loads it on my screen for me. Right? And now we see our beautiful outer space image, right? This image was added as a data member, right? On a space surface, right? This is all within my class game. You are seeing a visual representation of your object right now. This object has an image in it as a variable, right? And it's displaying it to you guys. Is this not cool?
It's cool.
It's really cool, man. All right. Now, let's go back to what we were talking about earlier. This is 0, 0, the positioning on it. Why do we put 0, 0? Well, the way that your screens work, if you did not know, the positions of your pixels starts from the top left corner of your window, right? So it actually maps the locations of every single pixel pretty much, right? At the very stop, or stop, what do I say? At the very top, right? At the top left corner, that is position 0, 0. As you increase or decrease, it goes left, right, up, and down on your window. And let's see that. Let's go ahead and change the position of our image to 400 on its x-axis. And let's run it again. Notice, right, that the image is now only halfway through my screen. Well, because for one, my screen is 800 by 800. So I put it at 400 by 0. So that means the x, which is going from left to right, is at 400, which is right here where my my mouse is at, right? That is x-axis 400, right? So I move my image to the right, right? Let's go ahead and add 400 to our y. And notice that it goes down now, right? The top left corner of that image is at 400 by 400. Our x-axis goes from left to right. As we increase our x-axis positive, it moves right. If we give it a negative, it moves left outside of our window. And same thing with our y-axis. Our y-axis, if we give it a positive number, it moves down. If we give it a negative number, it goes up. So it's a little reversed. So don't forget that, right? The y-axis is kind of reversed. Although you might give it a positive number, you would think it would move up. It does not. It moves down, right? And that's how the x and y coordinate works on your screens, right? Let's go ahead and put this at 0, 0. And instead of manipulating the window, I'm sorry, the image, let's manipulate the surface now. Notice that we place the surface on our display, but then we place the image on the surface. Let's change the surface to 400 by 400. And then run it again. It changed the image, right? Why? Well, because we added the image onto the surface, but the surface is on display. So because we changed the position of the surface to 400 by 400, that top left corner that you couldn't see, right, when we didn't have an image, it's right here now, right? But Roger, the position of the image is at 0, 0. Yes, it's at 0, 0 of the surface, not display, the surface, right? That piece of paper that we added on there. So even though that we drew the image and placed it at the top left corner of our surface, our paper, if we move the paper to the center of our desk, that image is no longer at the top left corner of that desk anymore because it's oriented to that surface. Does that make sense for you guys? All right. Let's put our surface back to 0, 0. Okay, awesome. So we finally got our nice little window, right, with a nice little background. Okay. All right. Now, next, let's add some actual functionality to this. Let's add something cool. Let's create our main character, our hero. No story, no game is complete with its main protagonist, right? So we are going to create our spaceship class now. So after creating your main.py file with our template, create a separate file and name it hero.py or name it spaceship.py. I do not care. Name it ship.py, whatever you want, whatever makes your heart happy. Right? So I'm gonna call this bad boy spaceship.py. And this is where our spaceship class will go. So just like our game class, we have to import pygame. So import pygame, and then we're going to declare our spaceship. So class spaceship. Everything else the same, just like you've learned so far. How do we declare or instantiate an object? We have to give it an init method. All right. Within this init method, it needs self. And when I create an object, it should have two things, right? First and foremost, I want to give it an image so I know where it should go at, right? Like what image it should be loading up. And I need to give it a position. So whenever I instantiate this object, it should automatically have somewhere to spawn at, right? To appear, right? So it should have the image that we have to load into it. And it should have an X and a Y axis, right? Now, within our init method, we're gonna give it a data member. It's gonna be called self dot underscore spaceship surface. So we had a surface for our background. Our ship should have its own surface for a reason, right? We don't want things to be on the same layer. When you think about your game, when you think about your program, I want you to imagine it like a layer of lasagna, right? You have different layers of stuff. You have different layers. On each layer, you do different things. Some you have cheese, on the other one you have sauce. There, if you just put everything on the same layer, things get mixed up, it gets messy, and we don't want that. We want to separate stuff. So whenever we do one thing to one, it doesn't affect the other, right? So the spaceship should have its own surface. And on this surface, we're going to give it our image. So pygame.image.load, and then we're going to pass in the image variable that we gave it here as a parameter. So whenever we instantiate this spaceship, it should automatically load the image into its surface. Next, we're going to create a variable called self.rect. Do not make this private. For some reason, Pygame will not recognize the location of your class if you make a rect data member private. So this is the only one that should be an exception. Just do not make it private. All right, this is just a Pygame thing. All right, so don't make this one private. So what is rect? Why do I call this rect? For those of you who do not play video games, right, we have something called hitboxes. Right? Do you guys know what hitboxes are? You know? Okay, of course you do, nerd. So hitboxes, right? Essentially, it's how your game tracks when something gets hit, right? So whenever you're playing Call of Duty or whatever you guys like to play, right, and you shoot at an enemy, how does the game register if that target got hit? Well, you don't see it, but everything has imaginary boxes that's being surrounded by. Whenever two boxes hit, right, the system recognize it and will trigger it as a hit, right? It'll recognize that two boxes have collided, they have touched, and that's how we recognize if two different objects have touched, right? Rect stands for rectangle, right? It's essentially just a box, right? We have to add a box to our spaceship. And this is going to come into play whenever we actually add some enemies on it. Whenever the box of the enemies attack, right, their bullet, their laser touches our box, our spaceship, our system needs to be able to recognize that they have collided, therefore triggering an event like, hey, you have died, right? That's going to allow us to not only track whether boxes have collided, but also we can use the rectangles that we're putting in here to position our object. So within this rectangle data, remember, I want you guys to add the spaceship surface that you created, and then you're going to give it the rectangle by using dot get rect, open and close parentheses. So this gives it a rectangle, and it takes a parameter. This parameter is going to be the position of where this box should be at. So because the spaceship is being put into the box, we give the box location, it'll move the spaceship with it and assign it a location of where we want it on our screen, right? You have different options of how to do this. You can do this middle is equal to X and Y. And you can do top is equal to X and Y. You can declare what part of your rectangle you want to manipulate. We want the spaceship to replicate the video game Space Invaders that we all grew up and loved. right? And you guys recall, where does the spaceship start at? It starts at the very bottom around the middle of your screen. So we're going to use the location mid bottom. Right, this is where our spaceship's gonna go. Within the spaceship, I want you to pass the X and Y. Our X and Y coordinates are being passed in here as data members. The init method on its own creates our image. It gives it a rectangle and it gives it a location, right? So right here in these two lines of code, we've already created where the image should be loading at with a box as well as its position. Now, we also want a method that's going to allow us to get that position when we need it, right? Because why should we be able to get the position? Well, when we start adding functionality like moving our spaceship, we're going to want to grab its X and Y coordinate and change it, right? We want to update it whether we move left, whether we move right, move up, or move down. So this get method is going to allow us to do that. So we're going to define get position. It should just take self, just like everything else, and it should return to us the X and Y data member from our rectangle, right? So it's gonna be self.rect.x and self.rect.y, right? Because remember, the X and Y are not working independently right now. We passed that to the rectangle, right? The image itself, we're not moving the image, we're moving the box because the box is what's holding our image right now. So to move the image, essentially all we have to do is move the box with it, because if we move the box, we move the image. But if we just move the image, the box won't move. All right, so we want to grab the X and Y from the box so we can move both of them at the exact same time.
Quick question, Roger.
Quick answer.
Up there on line 7, where you got mid bottom, that says equal XY, right? Equal
Correct.
parentheses. Okay.
If I need to zoom in my code, let me know. I can for you guys. We can do that.
Yes, that's a lot better.
No problem. After this piece of code, we'll take a break, guys. I know you guys probably getting burnt out. All right. So that gives it a location. Now, our spaceship class has been successfully defined, right? So now we can go back to our main.py. So after creating your main.py file with our template, we create a separate file and name it hero.py. We gave it its init method as well as its get position. After we create our spaceship, we need to code the functionality to allow it to appear on the screen. Right now, if we run our main.py, our spaceship does not exist here. Why? Well, we created the class, but we have yet to instantiate it, right? We have yet to assign it to a variable like our game class and then ran it. So we have to actually instantiate this object. The blueprint is made, but this bad boy has not left the factory yet. We need to actually make it, right? So after we create our spaceship, we need to code the functionality to allow it to appear in our screen. We can either do this in our game loop, or we can just give our class the method for it. In our example, we will create the method within our class. We will use the surface that our image is on, and instead of hand jamming the exact coordinates of our position, we can just pass our rectangle that already holds that, right? So within our spaceship, after the get position, this is outdated actually. Or ignore what I just said. This is outdated. I'm gonna do it differently. Let's not do it within the spaceship.py. Let's do it in our main.py. We're gonna instantiate it here. All right. So within our spaceship, within our main.py file, we're gonna go to our game class. At the very top, I want you guys to create a new data member. So we create a surface. After the space surface, I want to create spaceship. Right here, I want you guys to do self._spaceship. We're gonna create the spaceship.
I know it's awesome. It's really cool. Be able to see it like in action.
Yeah, it is. It is.
I'm back. Sorry guys, my internet is absolute horrible. I
McDonald's.
hope that didn't ruin the recording. I hope it did not. But let's get back to it. So we are creating our spaceship, right?
You got a screen share.
Okay, spaceship. As soon as we create our spaceship, we'll go on break, guys. I know you guys are probably tired, need a coffee or something. All right. So back to our game, right? We created our spaceship variable here. We're gonna go ahead and we're gonna assign it the actual object itself. So just like we instantiated this game object, within this game class, if you guys recall to the lesson, we can create objects inside of classes, right? And we're doing that again here in this example, right? So we're gonna do spaceship. Well, notice I'm getting an error here. Why is that?
Because you haven't imported it yet.
I haven't imported, right? I know it's a stupid question, but I ask these because you guys do this shit too. My bad, I didn't mean to cuss. You guys do this all the time too. You're like, oh, why isn't it working? Well, because we haven't imported, right? So I just have to harp on that. So from spaceship, import my spaceship class, right? Notice error is gone. Now I can actually create my spaceship. Well, what parameters does my spaceship take? Let's look at the spaceship. It takes image and an X and a Y, right? So we're gonna go back to the spaceship and we're gonna look for our spaceship file and we're gonna load up the dir spaceship.png. I don't know why it's called dir, don't ask me. Right, we're gonna load up this image. So open and close parentheses for the first parameter. We're going to give it the location of our file. We've already learned from our previous mistake about outer space. We need to go into assets / and then the name of our file, dir with 3 R's, capital S for space, capital S for ship, .png. Right? What else does our spaceship class take? It takes an X and a Y. Right? The X we're going to give it is going to be 400, right? Y, well, this is the X, right? So remember the X is from left to right. We want to move it to the center, so that means we want to move it right. So the X needs to be a positive 400. And then we want to move it at the very bottom of our window. So what's the height of our window? It is 800, so it's going to be 800 for the Y axis. Right, that will assign our spaceship. This will instantiate it, right? This instantiates our spaceship. So our spaceship exists, but it does not appear yet. Let me run it. My bad. It does not appear yet within our screen. I can print out. Jesus Christ, bro. Stop doing this. Okay. Our spaceship works, but it does not exist yet. But I can also do print self._spaceship and we can run it. And notice my game is running, but let's look at our console. It's printing out a spaceship object. So the object does exist, but we have yet to put this on our screen. So we need to add it to the screen, okay? So just like everything else, the way we did the display, the way we did the outer space, we need to blit this bad boy onto our screen. So
Quick question on line 19, the 400 and 800 don't need to be in parentheses.
negative, we declared this,
Okay.
right? We created this. This is taking the parameters in the same manner that we created the class,
Okay,
right?
gotcha.
That's just how we built it ourselves. So next we want to actually blit it onto our surface. So we're gonna go to our main. We're gonna scroll down. Where do we want to blit it on? On display, or do we want to blit it onto the space surface?
Would it be the surface?
Correct. We want to put it on the spaceship. I'm sorry, the outer space surface, right? Because if we put it on the actual display, we might get some weird functionality. One might overlap the other, depends on where it is on the line of code. So we want to blit it onto the space surface, right? So we're gonna go ahead and say self._space surface. dot blit, and then we're going to blit our spaceship in here. So it's gonna be self dot underscore spaceship, right? And where do we want to put it at? We want to put it on the X and Y axis that it has here, right? So it should be on the second parameter. We should just be able to do self dot underscore spaceship dot get position. And if we do this correctly, it should work. We have an error here on line 33. It says argument 1 must be a surface. Blah, 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 blah. But it is. Okay, let's take a 7-minute break and then I will debug this myself. All right, time is 7:35. Let's come back at 7:45. Not recording. Yo, thank you guys. You guys just saved me that. Thank you guys. I'm sorry for not recording. Quick little recap. I have to do this, guys, for those that watch the recordings. So earlier we couldn't get the spaceship to load. What we had to do was create a get method to grab the surface of that spaceship. So within our spaceship, we did get surface, and we return our spaceship surface data member, which is holding an image. And then we pass that within our space surface.blit method, get surface and get position, and that was able to give us something cool. I'm getting an error here when I run it. That was able to give us this window with the spaceship. All right, back to the thing at hand. So right now we're trying to add the functionality to our spaceship. So to grab the functionality, we can check when we press keys down, right? By using the pygame.key.getPress method. This returns to us a dictionary of the status of all the keys in the manner of true or false. And we see that here in our terminal. And it's just printing out nonstop. You can see this getting smaller. Look at it, just constantly printing stuff out over and over again of the status of all the keys, whether they're being pressed or not. We are getting false nonstop because no key is being pressed. The moment I press a key, one of these will turn true. Well, how do we grab which one is which? Well, if we go to the Pygame documentation, we can go to, I believe it should be key. And we get something like this, right? And it gives us the code for grabbing the keys that we are looking for. And we are looking for something like this, right? K underscore A, K underscore B, standing for key of A, key of B, key of C. And we're able to grab pretty much every single key within our keyboard. So going back to our code, if I want to grab a specific key, I want to do something like this. If keys, and then this is where we add the code. It will be pygame.ka. I'm gonna do my WASD, right? So I'm using I want to grab the letter A. But what if you guys want to use your arrows? Because some of you guys are old school. Well, let's look at this. We can get the up arrow, the down arrow, right arrow, and left arrow. And that would be K up, K down, K right, and K left, right? So actually, let's do that for you guys. So I want to move left and right. So let's say right. If I press the right arrow, I want to print out keys pygame.keyRight. If I do the left arrow, I want to do print the left arrow. Right? Let's remove the entirety of print keys so that way we stop getting all this extra input. Let's go ahead and clear this console because it's going to drive me mad. Clear. And now let's run this. So we no longer get all the extra input. I'm within my window. I'm going to click the left key. And we see it printed out true a bunch of times. Why did it print it out a bunch of times, this many times, when I only pressed it like once or twice? Because if you remember, it's a game loop. It's running this while loop like 1,000 times per second. So even though I just pressed the key for a split second twice, it printed out true multiple times. Because that split second, it ran this while loop that fast while I was pressing it, and it was able to return true. So within that split second, every time it ran, it caught it, right? Because of my left key, my right key. Now, I don't like using the arrow keys. I like to use WASD, so I'm gonna switch to D and A. And then I'm gonna add the rest of the functionality. If keys pygame.kw, let's print out keys k underscore w. Blah, 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 what am I doing wrong? Pygame. If keys is pygame dot ks, I want to print keys or pygame dot keys ks. Can get rid of this. Okay. All right, this should work again. Let's close this off. Clear, and let's run it. Did I do something wrong? I did do something wrong, and no one caught it. Keys. There we go. All right, we run this. I can press. Oh, there we go. That's weird. Okay, so it's tracking it. Right. Awesome. So that is working, guys. Now that we have the functionality to capturing the input of our keyboard, now we can actually do something. I want to go back to my ship.py, my spaceship.py. And in this spaceship, I'm going to give this bad boy a new method, right? This method is going to be called move, and it should just take itself as well as a direction. Now, this is what you guys are going to try to make this work. So I want you guys to create a method that's going to take in a direction, whether it's going to be moving left, whether it's moving right, up, or down. And if so, we need to change the position. What are we supposed to change? The X and the Y. All right, so we probably have to get, just like we did here, the X of the rect or the Y of rect, and then we have to change the position, right? Where are we going to add this method? When should that method be called? It should be called here, right? Right now, I'm going to go ahead and put pass so I don't get an error. But essentially, whenever I press blah, 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 if keys, oh, that's why I was getting some weird functionality. Okay, left should be A, key right should be D, W, A is D. Okay. Whenever I get some functionality here, I should be doing something here, right? It should be something like this, where I call my spaceship object and I say dot move. Right? Every time I press this key, whether it's left, right, up, or down, my spaceship needs to move. Right? I don't have to be printing this out anymore. I don't need to print out. The end goal is for my spaceship to move. Right? So this should be in here. Make sense, guys? Obviously, there's nothing being passed in my move right now, but I should be able to call this method. This method should take in some inputs We already see here, move takes in direction, and it should be doing something to the position of my spaceship. Time is 8:05. You guys got to 8:15 to get this to a try. Everything is pretty much done for you guys. Just add the functionality of the movement. I am here if you have questions. So we were supposed to add movement to our spaceship. We pretty much did all the functionality for it already. For our keys, right? We are able to grab a dictionary of the status of our keys, whether they're true or false, being either being pressed or not. And then we have this if statement that's checking if something is moving or not, right? If this exists, right? If keys Pygame K_D, A, W, or S, then we want to call the move method. Well, as I already declared earlier to you guys, it should be taking a direction. So if it's moving to the right, therefore my D key, it should take in a direction. We're going to use a string, right? We'll say D. If it's moving to the left, which is going to be my A button, should be A. If it's going to be moving up, it should take in W. And if it's moving down, it should take in S, right? That is my direction. Now, the actual functionality of it. We're going to check what the direction is. If it's moving one way or another, then we have to manipulate the X and Y axis. So if the direction, let's do our right first. If direction is equal to A, right? One of the strings that we're passing in, then we need to move our X axis to the right, right? Our X is left and right. We've already identified earlier when we talked about the X and Y axis that positive X axis will move it to the right, negative X axis moves to the left. So if the direction is A, then we should be saying self.rect.x plus equals, and let's just move it by 5 every time you press it. James is like, oh my God, that was so simple. I saw your face. It's like, what the heck? It was that simple? Yes, it was
I
that
forgot
simple.
the plus equals. I was just doing plus.
Okay, makes sense. Right. Right. Now, else if direction is equal to, let's say, D, which is going to be, oh, sorry, A was left. So let's change this to D because we're doing the right. This is going to be left. So if we're moving left, then X needs to go negative, right? So if direction is equal to A, then it should be self.rect.x minus equals 5. L if direction is equal to, let's say, S for down, then we have to change the Y axis, right? If it's moving down, we have already identified Y to move down is positive. So that means I'll do plus equals 5. And then we'll check if the direction is moving up, which is gonna be my W. Then I need to lower the Y axis by 5. Okay, now, this should work now. So let's go ahead and run the code. And we can see, wow, it is moving, guys. What is that? Pretty straightforward, very simple. All right? Yes, probably overthinking it. It doesn't have to be crazy. We're just moving X and Y axis. That is it. We don't have to do nothing complex. We're just checking, hey, is this key being pressed? And if so, update this X axis. If this key is being pressed, update this Y axis. And that is it. All the other functionality is being done on its own, right? For example, wow, how does my window know that it should be moving? Well, after all these keys get ran, what else is getting ran? Everything else. As well as what? Line 48, the display.update. It updates the screen to the new X and Y axis. Therefore, my image is now in a different location, so it pops it up there. And because it's moving so fast, you don't see like the image kind of frames kind of lagging or anything. It's a smooth transition. Okay, now I will give you guys 3 minutes to add a limit to this, because notice what should our spaceship not be doing? It should not be leaving our window, right? Because this is not like Space Invaders. Space Invaders, it has a left and right limit, right? And also, when we start making aliens, our spaceship should not be able to come all the way up here and spawn camp the images, right? It shouldn't be killing the aliens up close. So we're gonna add a limit to how far up it can move upwards, right? Give that a try, guys. I want you guys to add a limit to how far it moves right, how far it moves left, how far it moves up, and cap the up to about a third of the way downwards, right? It shouldn't move past like this area. Now, notice that the point that we are manipulating on our spaceship, where's it at again? Where's the rect being manipulated? It is the mid bottom. Keep that in mind, right? Because if you set a limit to not go past 0, this X, the X-axis, it'll stop you right here, right? Because we manipulate the mid bottom point. So we have to kind of mess around with the limit to ensure it's right at the edge, right? Because remember, we have the point right here at the mid bottom of our image. So give that a try in the next 3 minutes. All right, that was like 4 minutes. Let's get back to it.
I figured out one of them. I got it. I got one of them right.
All right. Awesome, awesome. We're getting there. All right. So next, we're gonna go ahead and add that functionality we were talking about. So let's work on the D key, right? So moving right, our object should not reach a certain point. So if we are moving right, it needs to stop. Where is my window? Oh, my bad. There we go. It needs to stop about right here. So this x-axis, because we're manipulating the mid bottom point of this object, which is right here. This is gonna be 800 right here. The edge is 800, so we probably want to have this around like maybe 780, give or take. So we can do something like an if statement. So if self dot rec dot x is less than or equal to 780, then I want to move it, right? If it's not less than or equal, then it should not move right. Now let's give that a try. We're just gonna mess around here, see how that works. All right, so we move it right, and then, okay, so 780 was not enough. So we're probably gonna have to decrease that a little bit more. Let's add some exaggeration here. Let's make this 700. So add 700, we go to it, and right there, give or take, should be where it should be at. So that stops it at 700, right? Okay, so 700. Now let's add the rest of the functionality for this. So for the left, if self.rect.x is greater than or equal to 20, then we can move it left, right? If it's equal to 20, it should not move any further left. We can run this, and there we go. We have a left stop, and then we have a right stop. Okay. Now for the moving down, if we're gonna say if self.rect.y is less than or equal to let's say 780, then we can move downwards. If it's got to 780, that means it's about to come outside of the window. So let's run it. So we come down, and 780 is not enough right? Let's go ahead and manipulate that again. And we will make this 700 again. Let's make that 700. All right, so we come down and it is right there. We'll keep it there. All right. And this is kind of how like you mess around with it, right? Your objects. And then for the top, right, we want it to be about a third of the way. So we'll say if self.y or self.rect.y is greater than or equal to 300, then move it. If it's less than 300, it should not be moving up anymore because it's getting too close to 0. Go back to our main.py. And there you go. That's about a third, give or take, a little bit more than a third. But that should suffice. That'll give enough time for the objects of the aliens to kind of do their thing and come out. Right, so now we have left, right, bottom, left and right limits, right? They're not allowed to go all the way down range, just to certain limits. And then they're still up here. All right, cool. And that concludes, guys, our movement, right? So we essentially did this. We added the movement for A, D, W, S. You guys were able to do the arrow keys. We gave it the X and Y axis or limits. And all this, once again, it's all being done within a class, right? You know, the X and Y coordinates are data members within our class. By changing this, we visually saw the representation of our object in its X and Y data members and how that affects it, right? And that's what's so freaking cool about classes and objects. And finally seeing how like an object comes to life in what your data members are doing, what your methods are doing. But now like does it make a little bit more sense? Like the methods are actual things that our objects can do, right? So that's pretty cool. All right. So we did that. All right, awesome. Our spaceship has liftoff. At this point in our code, we have reached modern space exploration, but it's time to kick it up a notch. We need to be able to defend ourselves from any possible threat. So for that, our spaceship needs to be able to shoot some form of projectile. For this exercise, we won't need anything fancy. Pygame allows us to create shapes which we can use as a form of projectile. And to do that, we are going to create a new file, and this is going to be our bullet class. So within your directory, we're going to create a new file, call it bullet.py. All right. Just like the spaceship in our game, we are going to import Pygame. We are going to create our class called bullet. We're going to do something different here. We are going to inherit from another class. So, if any of you guys are familiar with sprites are, sprites, when it comes to game terminology, are small little groups of the same thing or of the same general thing, if that makes sense. So we want to create multiple bullets, right? But it will get very difficult to have to manually code every single time that we shoot this bullet, right? So we need a way to track every single bullet that we create. Every single time our spaceship shoots and creates a new bullet object, right? That bullet object will be its own new instance, right? It'll have its own location and its own image. And instead of having to manually code for every single class, Pygame already does that for us. And it uses a certain class that's pre-built, and we can inherit from it. It's called pygame.sprite.capital-sprite, right? It comes with methods, and these methods are kind of like this, right? We created a move method for a spaceship where we can manually update the X and Y coordinate. And it's simple because we only got one spaceship. But what happens if you have multiple spaceships? and every single one has the ability to move somewhere at a different time. Like, how are we going to keep track of all that? Well, the Pygame.sprite.sprite class that we are inheriting from has built-in methods that groups all the instances that you create. It calls it sprites. It groups all the same instances and updates every individual one on its own. So you don't have to manually go through every single instance. It'll update them for you, which is why we are inheriting from the sprite class. Just think of the sprite as a group of instances of the same type of object, right? So we are going to inherit from the sprite class. We are going to initialize our method. It's going to take self like everything else. And the only thing our bullet needs is an X and Y coordinate, right? Of where we want this bullet to be instantiated at. Now, when you inherit from a class, you do not just magically get all these methods that come with it, right? You actually have to initialize the class that you are inheriting from. Think about it like if you guys has anyone of y'all seen the show Invincible on Amazon Prime?
Child friendly.
Not child friendly at all, right? But think of it like superheroes, right? When superheroes have kids, do these babies just come out and always have like their powers the moment they're outside of their womb? No, they tend to kind of grow up and eventually their powers awaken, right? So just like how they inherited these powers from their parents, they just don't magically can use them right off the bat. They kind of have to awaken them. In this instance, we have to initialize these powers, initialize these methods. Think of it in that manner. So we are inheriting from another class, but we don't automatically get every method right off the bat. We have to activate those methods. So to activate them, you have to do sprite or pygame.sprite.sprite, just like we inherited from, and then we have to initialize this as well. This does not need, yeah, it does need stuff, yeah. Right, we have to initialize it. The same way that we initialized our class to actually, have the object itself and use the methods, we have to initialize the class that we are inheriting from within this class, right? This bullet inherited from its parent, right? The pygame.sprite.sprite class, the ability to do certain things. And it needs to be able to awaken those methods. And that's what we're doing here on line 6.
Roger, is this like using the super function?
This is exactly like exactly like using super in it. If any of you guys have seen that in other code, right? We are initializing the methods of our parent class. So now, finally, after that's out of the way, we've created our bullet class in the method and we've inherited from our parent. We can actually start adding some functionality in here. We're going to give it an image, just like everything else that we have created. Just call this image. Don't make it private. It can get very funky on this bullet class. We are going to manually make a bullet. I didn't have an image for the bullet. I couldn't find anything cool. But as you saw in the README, Pygame allows you to create shapes. We are going to create a circle shape, right? And the way to create shapes is by doing the following, right? We're going to create an image with a surface. So pygame.surface, first parameter will be the size of the surface, which is going to be 10 by 10. It's just a small circle, right? The bullet should be small. It shouldn't be that big, right? It's supposed to come out of our ship. So the surface of our bullet should be 10 and 10. And then we're going to give it this method called pygame.src alpha. I forgot what it stands for. I think it stands for like the color, shade, or opacity of this. I don't remember exactly. Just know that this will create for us our image. You don't have to memorize this at all, right? Don't get humped up on this. The only thing that we're doing here differently is whereas on the spaceship, we loaded an image, right, to create our surface. Here, we're just manually creating one using the Pygame method, right? It's not important. Just know that this has a data member that's gonna take an image, just like every other class we've created so far. Then we want to draw our circle. So we're gonna do pygame dot draw dot circle. We'll pass in our image. We are going to give it a color value. We're gonna make it red, so it's gonna be 255 0 0 255. Next is gonna be the coordinate, which is gonna be 5 5, and then the radius of our circle. Right, these are just the methods that this circle takes to be created. Another thing that you do not have to worry about. Right, these are just methods that come with Pygame that we get creating. Right, essentially what we just did is instead of looking for an image and uploading the image, we are just manually coding a shape. Once again, this is not important. Right, don't get hemmed up on this. Now the rest should be the same. This needs a rectangle. We're gonna do self.rect is equal to. We're gonna pass in the image we created, and we're gonna give it the getRect method, just like our spaceship had. And then we're gonna give it a location, which is gonna be mid bottom. And it's gonna take the X and Y parameters that were passed in as arguments. Right? Still all the same, nothing crazy here. This is all still the same as what we did in our spaceship. We created a image for it and we gave it a rectangle so we can place it. That is exactly what we just did here. Only difference is the image itself, because we didn't have a picture, we had to manually create a shape. That's not really important. Just know that we created an image for it, and then we gave it a rectangle as well to give it a location. All just data members of this class. Now that we have that, we actually have to put it back on our paper, our screen, right? We have to draw it. So we're gonna go back to our main.py. And at the very top, we are going to import our new class. So from bullet, import bullet. All right. And here is where the parent class that we inherited from comes into play. This is why we wanted to inherit from a parent. So we can use these awesome abilities so we don't have to hard code classes. That's another thing about object-oriented programming, right? Inheritance, that's one of the pillars, right? You are able to create child classes that inherit from parent classes, and it allows you to reuse code without you having to manually code it, right? Think of it as like if you were the creator of a world, right? And you were creating people, right? People is the parent class, right? A person, right? What would be a child class, right? Creating Hispanics, creating whites, creating blacks, Asians, creating whatever you want to create. Animals, right? You can create a animal class, a creature class. You have different versions of them. You have uh, you know, lions, you have tigers, you have monkeys, you have chinchillas, and they all inherit from a parent class, right? Same concept. Um, Same thing. You just able to reuse a class to be able to uh, make a unique class from a parent, and that's what's awesome about code, right? That's another part of object-oriented programming. You don't have to reuse it. Imagine having to, as a creator, you're recreating the exact same class for everything. I have to create a unique class for, let's use nationality now, Americans, to create a unique class for Russians, a unique class for Chinese, a unique class for Mexicans, Canadians. Uh, but you can inherit from an overall, just like a citizen, right? Citizen can be the parent class, and then each child class could be an individual one that can be more unique. But we still have the functionality from a parent, right? Uh, pretty much every citizen should have a country that it belongs to, right? Maybe a passport, laws that it has to obey, stuff like that, right? Why manually code that for every new class that you create when you can inherit from a parent class that already has all these methods? Same concept. So, and that's important because when it comes to object-oriented programming and the 4 pillars of programming, that's a very common interview question. They will ask you, what are the 4 pillars of object-oriented programming? I've been asked that, name them. Okay, now explain them to me, which one's which, right? So being able to understand that concept. They will touch up a lot more on it in the immersive program. So now we're gonna come back to our main.py and we create our spaceship. Now let's go ahead and create bullets. So if you recall sprites, right? Want to make a group of sprites so we can track every individual one without having to manually code them. So we will create a variable called all bullets. Right, all bullets. This is gonna be essentially a dictionary of all the bullets that we have. And then within here, we're gonna use the command pygame.sprite.group. Right? And what this is gonna do is it creates a dictionary for us and it saves it to the variable called all bullets. And we can add every new instance that we create from our bullet class and save it within this dictionary. Right. So now we are going to go down to our while loop. So we have to group so we can add bullets into it, but we don't have any bullets for now. We actually have to create them. But when do we want to create a bullet? When do we want to instantiate this object? We want to do it at a certain event. We are going to use our, what did I use? Our mouse button, right? So within our while loop, we are going to come down to this for loop that we created, right? Where we are already checking for events. Before, the only event we were checking for was if we were quitting. Now we're going to check for a specific other event. And we're going to start off the same, if event dot type. And we are looking for a specific event. And this is from the documents, just like we saw how we were able to get keys, we can come up here. And there should be, where's that events. There's one for pressing stuff, right? We're looking for mouse button up, mouse button down, mouse motion, so we can track all these events. These are active events that the game tracks, right? We had quit, that's the one we used earlier. We're gonna use the mouse button down for our event. All right, so I'm not just putting this out of thin air. So if event.type is equal to pygame dot mouse button down, then I want to do something, right? Well, first and foremost, I need to figure out where the heck my ship is at, right? The bullets need to spawn at the barrel of my ship, right? The instance needs to be instantiated somewhere. So to get the location of my ship, I'm gonna create a variable. I'm gonna call this current ship location. Right, and luckily we already thought ahead and we created this variable called get position. So we will do self dot underscore spaceship dot get position, right? We're just using the get method to get back a data member from our class. Right, what this should return, and we can see here, print current ship location. So let's go ahead and run this. If I press my button down, I should receive in my terminal the current ship location, and we'll see that. There we go, 37, and I keep pressing it as I'm moving it. See how my ship location changes. So this works. It gives me my X and Y coordinate, and that's what I need because I'm gonna need to use those coordinates to figure out where my barrel is at. Right. So once I figure out where my ship is at, let's go ahead and remove this print statement. I want to create a new bullet object. So I'm gonna do bullet object is equal to, and then we're gonna call the bullet class. And what does the bullet class take? Let's look at it. We defined it. It's gonna take an X and Y coordinate. right? So the X and Y coordinate, we need to grab the current ship location and then add some changes to it, right? We're gonna have to manipulate the X and Y axis to kind of get it right at the barrel, right? So I've already messed around with the X and Y coordinates to figure out which one lands on it. But essentially I would do current ship location. And then I'm gonna grab index 0, right? Because it's essentially a set if you look at this, right? Index 0, index 1. So to get the x1, I need to do index 0. So I need to grab the index 0 location, and then I'm just gonna do plus 40. Right? So the x-axis for my bullets is going to be wherever the x coordinate for my ship is, but plus 40. Right? And then the y coordinate for my bullet is going to be the current ship location for its y, right? So index 1 plus 10. Right? Why am I adding these two arguments? Well, that's because that's what my bullet takes. It takes an x and y coordinate, which I'm going to use to instantiate the location. And I want to have it close to where my current ship is at. Next, this instantiates a freaking bullet, guys. This bullet is now here, but it's not drawn anywhere. We don't have it anywhere yet. But we are going to add it to this data. Remember, we created our dictionary of all bullets. That way we can track it. So we'll use self dot all bullets, and this dictionary has a specific method that comes with Pygame. It's called add, right? This is a sprite group dictionary. It's not a it's not a normal dictionary, right? This dictionary has methods that come with it, right? This method is add, and it allows us to just add it straight down there. So just put the bullet object in there. If this is a regular dictionary, we will use bracket notation, but this is from a pairing class that has this built-in method. I don't know how it works. I just know that that's one of the methods that it comes with, right? So I can add the bullet in there. Now, and now that it's in there, let's print out my bullets, right? Let's print out what my self_all bullet is doing. And see if there's even anything in there. It's not gonna draw it on here because I have yet to draw it or split it to the screen. But notice that every time I'm clicking my mouse button, it instantiates that object, that bullet here, and then it adds it to my all bullet group. And then I'm printing all my bullets. And notice that it says group, and then it tells me how many sprites are in there, how many instances, every time I click my mouse. So I know that there is objects being made. I just don't see them right now, right? Because I haven't blitted them onto my screen. So finally, we are going to blit them. And the way that sprites are blitted onto the screen is not the same as everything else that we have done. Remember, it's inheriting from a parent class. It has other methods. That's the reason why we inherit it. So we have to manually code these methods, right? It allows us to use the method that it already comes with, and this comes from the documentation and research. But we are just taking advantage of these pre-built methods. So we're gonna come down here from where we're bleeding everything else. And then we're gonna add a new line, and this is where we're gonna draw all the bullets. This is the main reason why I wanted to use a sprite group class, because I can just call the group of all my sprites, so all bullets, and it has a method called draw, and it'll take in a surface of where I want to put them. I'm gonna give it my space surface, and it'll draw it automatically into my screen, right? If I didn't use that sprite group, I would have to manually code everything all over again. But thanks to the inheritance, I don't have to do that. Then it also comes with another method that'll update. This is the second reason why I chose it, right? If I did not use this class that I inherited from, I would have to do some kind of for loop, go through every single instance, find the current location of that that class and have to like manually code it in, the change, but I can just use something like dot update. Right, dot update. Now, update, it's a default class. It doesn't really have too much of a functionality. It allows the user to give it our own unique functionality. The only thing that it does for us, it allows us to access everything within a group. It applies that method to everything within a group, and that's what I needed. We're gonna come back to the bullet class. We're gonna define update. And update takes in right now it's not gonna take anything, I believe. We're gonna do self.rec.y minus equals 20. Y minus 20. Well, we want to manipulate the y-axis because we have to make it go from down to up, right? We're trying to change the direction of where our bullet is going. And we're gonna do that on the update. Let's see what it does if we don't add update. Let's see what we got so far without the update. Let's run it. We run it, I click it, and look at that. There's a red circle on my screen, but nothing is happening. I'm creating my instances. It's all within a group, and then I'm drawing them on my screen, but it's not moving. It's not updating. Now, let's go back to the update method, that pre-built update method that comes with our group class. I uncomment it out, run it again, and look at that. We got a shooting spaceship. Isn't that cool? A shooting spaceship, right? We created an object called bullet. We were able to inherit from another parent class, and then we were able to display it on our screen. That's going to conclude today's class, guys. It is 8:54. I do not want to waste any more time on anything else, because I want to leave room for any questions. I'm gonna stop my recording now. Actually, not yet. I'll leave it open for questions, but we have like 6 minutes for questions. What do you guys have for me?
Real quick, would you mind if I see the update function under bullet.py? I
Yes.
think I missed that.
While he looks at it, you guys have anything for me? What are your questions? You have any comments or questions at all? Your thoughts? Speechless.
I liked it.
I just need to read more about the pie game as far as on the documentation, but like you said, it's just to show us about the objects, but I like it and I get it. It's a little confusing with all the display updates that need to take place, but
Yeah, so I know, right? Um it feels a little overwhelming. Like, what is all this information? It's the information about Pygame. Pygame, the module itself, doesn't really matter. We are using Pygame as a tool to help us put it on our screen, right? Because if you guys were to run Lemonade on that Py, ain't nothing popping up on your screen, guys, right? All you're seeing is just the code in your console that you are manually coding in there just to show you're playing with yourself, right? That's not fun. Pygame, we are leveraging the method that it comes with so we can see a visual representation of our objects being instantiated in real time, right? So we can visualize what methods can do for us, right? So if you guys were having a difficult time wrapping yourself like class and objects and instances and what these methods are doing, like all these data members, like I don't understand how this method can do this for this data member. This is what it's supposed to help you with. Just understand how we can bring this to life and how these different methods are actual actions that our objects can do, right? These are functions, right? It almost gives your class and your objects almost like a sense of life, right? Like you are creating like a little thing that can do stuff, right? And that's what's cool, right? That is the main point of it. Not it's not to get hemmed up on like what the heck is Pygame dot event. Who cares about all that? That does not matter. Just visualize it and see that this is how like you know a class is built, just like game, right? How a class can be built inside of a class, right? We instantiated the spaceship object, we instantiated the bullet object within the definition of a class, right? You guys were a little confused about how that is done before. Just know that we can do that, right? We can save it to a data member, right? We can use it within the methods of another class. We just saw inheritance. You saw how like we created a bullet class and it can inherit from some other class that we didn't create ourselves, but we had access to its methods, right? Because of inheritance. And that is the main point of this, right? Not how to display this. Who cares? That's just a tool so you can visualize, right? Anybody else? Any other comments? For those of you, many people like Kim who didn't like this, I'm working on another lesson, and it's not a game, but it's a GUI, a graphical user interface. It's called tkinter. It comes with Python, and it lets you create applications, and it opens up a window, and you can do stuff with it, like create buttons and display lists and stuff, whatever. Think of like the Anki application that I showed you guys. It can create small little applications like that. I'm currently building lesson plan for that. Uh, for Lemonade Stand and for the streaming guy, so they can visualize that as well. Uh, what do you think about it? What are your comments and thought process? Do you think that would be more enjoyable for people like you who cannot relate to this kind of things?
Yeah, I'd be excited to do that for sure. Yep.
Okay.
I'm probably an anomaly though that isn't interested in gaming, so it's just
I
hard
mean,
to get excited about do
we're,
that.
it's okay. We all have our own things, and I just want to make sure, because Pygame, the biggest issue with Pygame that I encounter is like, oh yeah, I feel like Pygame is too much. I don't understand it. I'm confused. It's hard to find something for the students to visualize, for you guys, because no code that you just run manually will open up a window. It typically takes a third party library, or a third party module. Uh, so for the GUI one, it's called tkinter. It's another library that you have to import, and pip install, but that itself has its own methods too, right? Tkinter do this, tkinter that, display this, tkinter dot button. Like it has its own methods that it comes with. So there's still like a learning curve for any kind of module or library that I will use as a tool to help students learn. I'm just want to ensure that I can help reach students, get to that point where they finally understand and that light bulb clicks. Like, okay, I can kind of see and understand what these objects are doing now.
Yeah, I told you you're brilliant. This is great. I'm sure this set off a bunch of light bulbs. So this was a really good lesson.
I do apologize, guys, for any typos if the readme is not perfect. I told you guys I built this over a weekend, um, and I haven't gotten to update stuff, but also I don't touch it between 3 months, so I have to go back. Like, oh, okay, I forgot how I did this, but yeah, and you guys can do stuff like this too, guys, right? So, when you guys have downtime, whatever, there's so many things out there for Python and JavaScript, so many different frameworks and modules and libraries are available to you guys. You guys just don't know, right? It's just honestly ignorance. We just aren't aware of what's out there. We don't know what we don't know. But there's so many cool things out there to help you do different things. Whether you like building video games, whether you like building GUI applications, whether you like running scripts to run things on your computer, right? Or let's say you work in a tech job and you're not necessarily a coder there, but maybe you can run a script that can help you automate your processes, right? So there's many things that you guys can look out there and find that'll help you guys in your day-to-day life and just kind of experiment with, right? Code kind of it's the future of language, I believe. That's where technology is going. So, yeah, I think the CEO of NVIDIA actually said that he thinks that we're going to come to a point where everyone's going to know how to code. It will be like the standard, like to kind of understand a coding language. And you see that in business too. Even if it's simple stuff like SQL or whatever, people are starting to do it on uh in their daily jobs. But all right, guys, it is 9:02. I don't want to take any more of your time. Thank you for your cooperation. If you guys have any questions, do reach out. Um, do not go ahead on me on this lesson, Gary. So you guys don't get confused. But we will continue this tomorrow. Tomorrow will be the last day we do this, and then we'll move on. By the end of tomorrow, we should have a full game, and we can go back and talk to the code and kind of, just see how that works. But I hope you guys enjoyed it. But yeah, you guys have a good night. Thank you all.